So properties of parabolas, y equals ax squared plus bx plus c. A is going to be a key idea that we're going to focus on today in terms of understanding our vertex. And so the first major idea as we look at this is the value of a. So if a is positive, if a is a positive number, the parabola is going to be in a U shape. If a is a negative number, then the parabola is going to be an upside down function. Now these are very similar to our tent and our valley for absolute value. Remember, when it's positive, it's a valley. When it's negative, it's a mountain or a tent. And so we have a very similar situation here. How do you know that? You look at what's in front of the A. Is the A positive or is the A negative? Very straightforward there. Now, and these two little parabolas I've drawn, I'm going to put a dot there and a second dot there. The blue dot represents the bottom of the graph. That represents a minimum. The green dot represents the top of the graph, and that represents the maximum. And so if I ask you if a parabola has a max or a min, you don't really need to graph it. All you need to do is look at the A term. If the A is positive, it's going to be a min. If the A is negative, it's going to be a max. Pretty straightforward there. Some people say, what about the graph? You don't need to graph it. You can recognize it just in the value of A. Okay. Now, moving down. The most important formula that we're going to do today is the axis of symmetry. X equals, this goes back to Algebra 1. Do you remember what it was? Close. The opposite of B over 2A. And that's part of the quadratic formula. Part of the quadratic formula. So x equals the opposite of b over 2a. Hugely critical that we know that. Huge. Just making sure we have that. To find the vertex, we take the opposite of b over 2a, and then we plug it into the function, whatever the function is, and we get our value of y, and we're going to practice that today. To get the y-intercept, that's just 0, c. All right, so that's kind of our overview. You can kind of review back to that as you're kind of doing your homework tonight and things like that. Here's our steps that we talked about. We're going to first find the axis of symmetry. Second, we're going to find the vertex. Third, we're going to find the y-intercept and a reflected point. And then lastly, we're going to choose a point and find the reflection of that one. So here we have two graphs as we're looking. This one is obviously a valley graph, and so the A therefore must be what here? And I kind of wrote that. A must be positive. And here it's a mountain, and so this A must be what? Negative. This vertex right down here is what kind of point? Max or min? Min, and this vertex is a max. So we find the y-intercept. We say, okay, this is a prescribed distance away from the dotted line. And then we go that same distance away for our reflected point. The same thing here, this y-intercept is a certain distance away from the dotted line. And so we go that same distance away for the reflected point. And so those are going to be very easy to do with graph paper. Really strongly suggest on your OneNote tonight you use the graph paper in terms of the mode of style of lines that you're going to work with. All right, so I have three equations we're going to graph today. Each equation presents a little bit different position, a little bit different idea to go through it. The first thing we're going to have to do on all of your problems tonight is identify A, B, and C. So what's my value of A here? Negative 1. Okay, so let's put that in. Negative 1. What's my value of B? 4. And my value of C? 2. All right, so on your homework tonight, I strongly encourage you, every time you start this kind of a problem, write the axis of symmetry and write the equation, Sebastian. X equals the opposite of B over 2a. Just write it every time. That way, by the end of the problems in your homework, you'll kind of have a good feel of what that is. So let's plug these in. X equals the opposite of 4 over 2 times negative 1. What does that simplify to? X equals 2. Okay. Now remember, when we ask you for the axis of symmetry, Zach, we've got to make sure we don't just say it's 2, we say it's x equals 2. It's a line. So go to your graph now and go to the value x equals 2 and make a dotted line up and down at x equals 2. It's dotted once again because it's just a reference. It's not really there. Now, we take that value of 2, and we're going to put that value of 2 back into our original problem. So I'm going to just copy that down here. Y equals negative x squared plus 4x plus 2. And we're going to put the value of 2 into there to try to find the value of y. So here we are. We're putting in the value of 2. Please realize I'm squaring the 2, then Moss taking the opposite of it. Because it says minus x squared there. And so that first part is not going to be positive 4. It's going to be a negative 4. So negative 4 plus 8 plus 2. That's negative 4 plus 10. I get 6. So my vertex, 2, comma, 6. So go up on that y-axis, over to the dotted blue line, and go up to 6 and put a dot there. Think with me. Is this graph going to go up like a glass or go down like a waterfall? It's going to go down, okay? We know it's going to go down because the a value is negative. Next step, easiest step on our homework, on our material today, is the y-intercept. The y-intercept is always going to be 0, comma, c. That's it. So we go up to our values. The value of c is 2. So that leads us to 0, comma, 2. Really easy. So plot that point. 0, comma, 2. Madeline, how far is that 0, comma, 2 from the dotted line?
It's 4 points, like 4.
Okay, it's up and down 4, but how far sideways to the blue dotted line? 2. So I'm going to go 2 units the other way and make my reflected point. Do you see the fact that it's now going down, Luke? Okay, see how it's kind of is falling down. I need one more point. Now, we have some choices here. We've already chosen the value x equals 0. We've already chosen the value x equals 2. We've already chosen the value x equals 4. So you could choose the negative 1 idea, the positive 1 idea, the positive 3, or the positive 5. Which would be easy, which would give us a good framework? Positive 1, okay, so let's try that. Once again, so we're going to choose our point, positive 1. So that's just a choice. Choose x equals 1. So the opposite of 1 squared plus 4 times 1 plus 2. That's negative 1 plus 4 plus 2. That's what, 5? So we have the point 1, comma 5. So go up to your graph. 1, comma 5. There we go. How far is 1, comma 5 from the dotted line? 1 unit away. So we go 1 unit the other way. Good morning. Grab a seat. You can sit, both of you can sit right here. Welcome, Shadow. Glad you're here. So we've got a parabola going upside down. So let's sketch it. And there we go. What's that? No, you just want to make sure you have arrows there. You want to make sure it's not flaring out, like a landing, but going, kind of straight down and going from there. Now, remember our pattern yesterday? We talked about 1, 1, 2, 4, 3, 9. So because the value is a 1, you could do that 1, 1, 2, 4, over 3, down 9. So that would be 5, 6, 7, 8. So there would be another point right there. So I wasn't a very good drawer here in terms of that. That would be kind of another point for that pattern. Oops.
So how do you know, the y-intercept in that?
How do we know the y-intercept?
Yeah.
Well, that's the value of c. See the value c equals 2?
Okay.
Just very simply c equals 2. Whatever the y-intercept is. And that's why this is kind of a whole package as we look at the whole process all together. And I kind of try to spread it out to give you plenty of room to work and things like that. Questions here so far? Who?
Sorry. So the slope of the top of the parabola is always like -1. And then
Well, that is determined on the fact if the a value is either 1 or -1.
the a value is slope.
There's not really a slope of a parabola.
It's like this.
It tells you the direction it opens. If a is positive, it opens up. If a is negative, it opens down. So, all right, let's look at our second example. And hopefully as we do these, we'll get a better feel for these. All right, A, B, and C. What's my A value? 3. All right. What's my B value?
-12.
-12. And C? 10. All right. You guys plug in for the axis of symmetry. See what you get. You should end up with x equals a number.
I don't have a service now. You paper and pencil will practice this. I don't put engage, not engage. I don't do it. Yeah.
Oh, 1, 1, 2, 4, 3, 9. Remember the pattern we talked about yesterday? That only works though if a equals 1. All right, so here we go. Axis of symmetry. X equals the opposite of -12 over 2 times 3. So what does x equal? Again, perfect 2. All right. So once again, you're going to make a dotted line at 2. Trust me, that will not always happen, but it did in this case. Now let's find our vertex. I would encourage you to rewrite the equation down here. 3x squared minus 12x plus 10. So let's plug in the value of 2. So 3 times 4 minus 24 plus 10, 12 minus 24 plus 10. That's 22 plus 10. Or sorry, 22 minus 24. I get -2. Do you agree? So my vertex, 2, -2. Let's put a dot on our graph, 2, -2. There we go. Tell me, which way does this graph open? It opens up. How do we know it opens up, Richard? Any idea? Jonah, any thoughts? Why does it open up? Richard?
It's positive.
It's positive, yeah. The A is positive. That's why it opens up. So we know our basic sketch is up. Now, Luke, you asked a good question before. On the first one, the pattern was 1, 1, 2, 4, 3, 9. That's because, Luke, the A value was either +1 or -1. That is not the case down here because our A value is 3. So this parabola is going to be much narrower. Much narrower. Not 1, 1 anymore. We're going to kind of see what that pattern looks like. So what is my y-intercept? What is the C value? 10. So instantly we have my y-intercept. C equals 10. The y-intercept is 0c. So my y-intercept is 0, 10. So we are almost off the graph, if not. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you're going to have to estimate there. But you're putting a dot way up the graph. Why is it so high? What's causing it to stretch again? The A value is causing this thing to stretch. Okay? So let's go over here. Reflect that point. How far is that second green dot away from the dotted line? The same distance. All right, I feel like I need some kind of form in between 2 and 0. So you could put in the value x equals 1, or you could put in the value x equals 3. Which would you prefer? 1. Okay, it's easier. So we're going to choose the point 1. So choose x equals 1. So 3 times 1 squared minus 12 times 1 plus 10. Paul, can you work that out for me?
Yeah, that would be 3 minus 12 plus 10.
Keep going.
Simplified, that's 1.
That's 1, okay. So we have the point 1 comma 1. So let's graph that. How far is that purple dot from the dotted line? 1 unit. So flip it over and go 1 unit the other way. You now have your 5 points. So you should be able to sketch your parabola. Comparatively, how steep is that? How much is that? Okay. 3 times is narrow. I think we've answered all the questions on this one except for the final one. That red point, is it a max or is it a min? It's a min. Did we answer that on the first one? That red point, max or min? That's a max. Questions on this one? Any questions? How many remember this from Algebra 1? Some of us, okay. All right. I saved the third one. Made it really the easiest one of all 3. Tell me A, B, and C. Which one tell them to me? 2, 0, -4. Now, special case. Super easy special case. If b equals 0, so many nice things happen here. The parabola Anna is sitting right on the y-axis, first of all, because b equals 0. Because watch what happens. If b equals 0, you have the opposite of 0 over 2 times 2, which means your axis is x equals 0. So I guess we can put our dotted line right on the y-axis. Secondly, when you plug in the value 0 for your vertex, we have 0 squared minus 4, which equals -4. And where else do we see the value -4? That's the value of what? C. So the vertex is always on the y-axis, and it's always at the y-intercept. Why does all this happen? Because b equals 0. So the y-intercept is almost a mute point. 0, -4. Now the good thing about this is it's easy to start with. A little bit more challenging is we still need 5 points. And that's why at the bottom we have 2 lines to choose. Now, I would assume you could choose maybe x equals 1, x equals 2, x equals 3. Any one of those. Or over here, x equals -1, x equals -2, or x equals -3. Which would be good calls or good choices? Okay, 1. What else?
-2.
Why would you go to a negative number? Just curious.
Well, you
Just to make it challenging?
just reflect it, so.
Okay, so let's start with this one. 2 times 1 squared is 2. 2 minus 4 is -2. So that's the point 1, -2. So we're going to come up here, 1, -2. I take that green dot, and what do I do with it? Reflect it. So now I'm coming over to there. I now can either choose +2, +3, -2, or -3, which will be the safest and easiest point to choose. +2. So let's choose that. 2 times 2 squared minus 4. 2 squared is 4. 4 times 2 is 8. 8 minus 4 is 4. So we have the point 2, comma, 4. We sketch that. 2, comma, 4. And we flip it. Got a pretty good feel of what our graph looks like. Questions there? By the way, our red dot, our vertex, max or min? Min? Okay, so let's put that down there. Now, any questions?